Section 7.3 is going to be the law of cosines. In 7.2 we looked at the law of sines, and we can only solve certain triangles using the law of sines. So now we're going to look at how we solve some other triangles using the law of cosines. Now this will work for the case of side angle side or side side side. So whenever you're given the angle between two given sides, or whenever you just given all three sides. All right, what does it say? If triangle ABC has sides of lengths ABC and so forth, okay? All that means, that first part is, suppose you have a triangle and you call this angle A, then A needs to be across from it, lowercase a. If this is angle B, lowercase b is the side across from it. If this is angle C, lowercase c is the side across from it, okay? And the law of cosines is this stuff. Now, don't get overwhelmed by this stuff. Think about what this means, okay? Let's see. What if I want to look at this first one, okay? A squared is equal to b squared plus c squared, okay? Let's say that you were looking at finding a, for example, lowercase a. Then you would say a squared is equal to the other two sides squared, added up, minus 2 times those other two sides, times the cosine of the angle opposite of A, okay? And really the same thing for each one of these, okay? Let's suppose you try to find B here. So you would say B squared is equal to the other two sides squared, added together, minus 2 times the other two sides, times the cosine of the angle opposite side B. And the same thing for C, okay? If you put it in your own words like that, I think it makes it easier. Well, let's see. Let's go on to our first example of this. All right, our first example. We have solved the triangle, round decimals and calculations to 4 places, and final answer to 1 place. So our first example, we're going to have lowercase b is equal to 89.2, lowercase c is equal to 23.1, and capital A is equal to 108 degrees like this, okay? And we want to solve that triangle. All right, so just draw you any old triangle up here, okay? I'm going to draw a triangle that looks like this. It doesn't matter. You're just using it as a visual. I'm going to say, okay, this is angle A right here, okay? Angle A is 108 degrees. All right, across from angle A is side A. Now, let's go ahead. I guess we can call this B. It doesn't really matter. So B, or side B, is going to be 89.2. And if I call this angle C right here, opposite of it is side C, which is 23.1. All right, so now I have a triangle that I could use a visual for. All right, so let's see. Let me ask you this. Could I use the law of sines to solve for here? If I tried to use the law of sines, I'd have like, don't write this down, I'd have the sine 108 degrees over A is equal to the side of, I don't know, maybe B over 89.2. Notice though I have 2 unknowns if I try to use the law of sines here. So the law of sines is not going to work here. I have too many unknowns. So what we're going to do, so we're going to say, okay, I have side, angle, side. So I'm going to use the law of cosines. Now, if you look at your notes, you have a guideline or guidelines for solving side, angle, side case. Okay, number 1 says, find the length of the side opposite the known angle. Find the length of the side opposite this known angle. So that'd be A. So A squared, according to my formula for the law of cosines, is equal to the other two sides squared added together. So 23.1 squared plus 89.2 squared. So the other two sides squared added together, minus 2 times the other two sides, minus 2 times 23.1 times 89.2 times the cosine of the angle opposite of A. Angle opposite of lowercase a is 108 degrees. There There's my formula right there. Law of cosines. Now, if I want to solve for A, I'm going to take the square root of both sides. So I'll say A is equal to the square root of all this stuff. And I'm just going to write it down like this because I'm just going to put this whole line in my calculator. 89.2 squared minus 2 times 23.1 times 89.2 times the cosine of 108 degrees. And go ahead and put the radical and all in your calculator and calculate this. All right, so whenever you finish doing this, you should get something like 98.8115. And the directions said round to 4 decimal places, and then at the very end, round to 1 decimal place. All right, so I found the side opposite my given angle. Remember those guidelines for solving side angle side case? We did number 1. How about number 2? Use the law of sines to find a measured angle opposite the shorter side. Opposite the shorter side. What's my shorter side here? 23.1 or 89.2? Actually, it's opposite the given shorter side. Well, this side's shorter, right? So we're going to find angle C next. So how did I choose C? Because it's opposite shorter. Now, why do we do it in that order? Because sometimes if we don't do it in that order, we're going to have to consider the ambiguous case. And I want to stay away from that. That's more work to do if I consider an ambiguous case. So if I go with the shorter one, it's going to be an acute angle, so we'll not have the ambiguous case. So what am I going to do? I'm going to use the law of sines to find angle C. So the sine of angle C over 23.1 is equal to the sine of angle A, which is 108 degrees, over side A, which we just found to be this number, and use it with those 4 decimal places, 98.8115. Actually, I wanted to do that in the last section, carried out to 4 decimal places, but for some reason Alex was not doing that, and it throws your answer off. So if they're not doing it and you are. All right, so cross multiply and you get what? 98.8115 sine of C is equal to 23.1 sine of 108 degrees. Now divide both sides by this 98 number. And you get the sine of C is equal to 23.1 sine of 108 degrees over 98.8115. So how do you solve this? Take the inverse sine of this stuff. So C will be equal to the inverse sine of 23.1 sine of 108 degrees all over 98.8115. Let me back up so y'all can see. And then what do I get here? Whenever I look at this rounded to 4 decimal places, I get 12.8463 degrees for angle C. All right, what's next? I found side A, found angle C. I still have to find angle B. So for angle B, all we do is we say, okay, that'll be 180 total degrees in a triangle, minus 108 degrees, minus 12.8463 degrees at other angle. And if I calculate this, I get B is approximately 59.1537 degrees. And let me list my answer here. And let me round my answer to 1 decimal place. So I got A was about what? 98.8. Angle B was about 59.2 degrees. And angle C was about 12.8 degrees. There we go. Using the law of cosines.